Okay, then, if we don't have any questions on Chapter 5, let's move right on to Chapter 6. And I really think Chapter 6 is the easiest chapter that we cover. Okay, and like I said, it may be a review for something you've seen in the undergraduate. This is called decision analysis. And we're going to expand it a little bit, maybe based on what you saw in undergraduate, but it's very similar. So we make decisions every day, and the world of business is about making the right decision. Right? We only have so much resources, so much time. We need, as a manager, to make the right decisions in a variety of different situations. Okay? So what decision analysis does is it doesn't decide for you, which would be nice, but it provides a framework for you to make a decision. Instead of us just saying, hey, this one feels right, I'm going with my gut, which is also valid, this provides a framework to look at decision alternatives under future states of nature and decide what might be best. Okay? So it allows us to select a decision from a set of possible alternatives when uncertainties regarding the future exist. Our goal, like our goal in everything we've done so far, is to optimize a result in terms of a way we look at the decision, what we call a decision criteria. You and I may have different views of what is optimal, especially when we make a decision. Okay? So let's, maximizing profit is usually good, utility, which is happiness. Let's start talking about some of the tools that we use for this. The first tool is something called a payoff table. And a payoff table looks like this, and I'm just going to use an example to kind of show it. We have a finite set of decisions we can make. We have future states of nature, or future events that can affect those decisions. And if we make a decision and this happens, we can estimate, hey, what's the payoff we're going to receive? And it's a two-dimensional spreadsheet or table, if you will, that's used to represent that situation. Here's our decision alternatives. Here are our future states of nature. And here is the payoff that we might realize. So just to put it on the board to give you an example, I have, let's say, 3 decisions I can make, decision 1, decision 2, and decision 3. And how good these decisions are based on some future state of nature that I don't know anything about. Okay? So we'll call this state of nature 1, state of nature 2, state of nature 3. Where they intersect is the payoff. So let's just say 50, 100, negative 100. Let's say this is 75, 75, 75. Say 250, negative 200, and negative. All right. So if I make decision 1, whatever it is, and this happens, this I don't know, but these are called future states of nature, I'm projecting my payoff is going to be this, 100. If I make decision 2, and this happens, or I'm sorry, state of nature 3 happens, I get this payoff. If I make decision 3 and state of nature 1 happens, I get this payoff. But generally speaking, these things aren't known. Okay, the states of nature, they are not known. So we want to apply a set of criteria to it and see algorithmically, mathematically, what makes sense. So in a payoff table, the rows correspond to the possible decision alternatives, boom, boom, boom. The columns correspond to the possible future events. And the table entries are the payoffs. The payoff we receive if we make decision 1, and then this eventually happens. All right, so the best way to explain this is a little table here. Okay, Tom Brown has inherited $1,000, and he has to decide how to invest the money for a year. Okay, he has, I know I think in our TIA prep there's about 18 or 30, which is a lot of investment options, but we'll say Tom only has 5 choices where he can put this $1,000. He has the gold, junk bond, growth stock, certificate of deposit, and a stock option hedge fund. Now, how well they perform, is based on how the market does. Okay? So we say gold, bond, stock, CD, stock option, and here is the future states of nature. And a couple things about the future states of nature. They should have the following characteristics. They should be mutually exclusive. What does that mean? What does mutually exclusive mean? Tyler, if you're dating someone mutually exclusively, what's that mean, Tyler? Brady? You date that person to the exclusion of everyone else, right? Okay? That's what mutually exclusive means here. If the large rise happens, the small rise doesn't, right? Basically, one of these future states of nature is going to happen, excluding the rest. Okay? Mutually exclusive. The other principle is the future states of nature are exhaustive, which means it covers all the possibilities. Even if the Dow goes up 1,000,000 points, well, it's still in that category. Dow is up more than 1,000 points, right? Even if it goes down 5,000 points, well, it's still in Dow is down more than 800 points. So it's mutually exclusive and exhaustive. Now, how we read this, okay, is if Tom invests in gold and the market goes up, I don't know, somewhere between 300 and 1,000 points, we're projecting he's going to make $100. That's a projection, right? That's our projection. If he invests in bond and the Dow goes down more than 800 points, we're projecting that he's going to lose 150. Okay? So this is a payoff table. Okay? The states of nature are mutually exclusive and quite what we're talking about. Okay. Here are the set of possible decision alternatives. Here are the future states of nature. Now, what decision would you make? I'll pick on Lou. Lou, if you were Tom Brown and you presented this payoff table and these states of nature, what decision would you make? Can't be wrong there.
Stock large rise.
Okay, you're going to go stock. Well, yeah, you stock large rise, but you don't know these, right? This is unknown. This is future states of nature. So if you invest in stock, you're hoping, right? You're hoping the large rise happens. But if you invest in stock, it could also be a large fall and you lose 600 bucks. So given that, lose still, that's fine. You can still say stock.
I can do that.
All right, you'd go gold. Okay, so gold, negative 100, 100, 200, 300, 0. Okay. Chris, how about you?
Sometimes playing it safe and CD.
All right. I like how you said that. He said, I was playing it safe. So he said his decision criteria to play it safe was going to go with CD. Anyone else? Would anyone else go with stock? Yeah, Tyler would. Tyler's a gambler. He'd go for it, right? He said big return, 500 bucks. Also a big loss, right? No problem, okay? Who's right and who's wrong? No one's right, no one's wrong, okay? We applied subjectively different decision criteria. You said, I'm going to play it safe, went CD. Tyler said, I'm going to go big or go home, he went stock, okay? And Lou was kind of in the middle, said, yeah, given that, I'm going to hedge my bet a little bit and go gold. Now, what we're going to do is we're going to apply a set of structured decision criteria to this to say, what would we do under this set of decision criteria, all right? First of all, I want you to notice, the bond and the stock option options. The bond and the stock option options. What do you notice if you compare the bond to the stock option in every case, under every future state of nature? Do you notice anything consistent about it? John? Yeah, in every situation, the bond is as good or better than the stock option has. So unless there's some other variable that we didn't quantify here, there's not really a reason to ever go with the stock option, right? If the bond is as good or better in every possible future state of nature, then there's no reason really to go with the stock option hedge. We call that, it is dominated. Okay, we call that the stock option alternative is dominated by the bond alternative. And oftentimes, when we have a decision criteria like that that's, hey, it's never any better than something we already have, we just eliminate it from the payoff table. We're never going to choose it using a rational algorithm. Now, there may be other reasons we choose it. You know, we just have a good feeling, whatever. Those are valid decision criteria we use every day. But in terms of this, we wouldn't choose it. All right. So that is our payoff table. Okay? Now we need to look at some decision-making criteria. And there are three categories of decision-making criteria that we're going to talk about. The first one, it all has to do with the future states of nature and what knowledge we have of them. Okay? So it's all depending on the states of nature and what knowledge we have of them. The first one is decision-making under certainty, meaning we know what's going to happen. Now that's not a hard decision. Lou made that decision. If he knew there was going to be a large rise, Lou, you're going to go with what? Lou, if we know there's going to be a large fall, what are you going to go with, Lou? Right, exactly. Those are easy, yes? So decision-making under certainty, we don't really need to do much here. Okay, at least it doesn't apply. Sometimes we know what's going to happen, we still don't know what decision we're going to make, right? But in terms of this payoff table, we don't need to apply any criteria. It's pretty damn easy. Now the two that we're going to talk about are decision-making under uncertainty is the first one. And under uncertainty, I don't have any likelihood, I don't have any knowledge about the probability of the states of nature occurring. I don't know if this is more likely or less likely than this. I don't know if this is a 1% chance or a 99% chance. Uncertainty means I have no clue. I couldn't even assign a probability to these events if you force it. Total uncertainty. I don't know. Okay? I have no knowledge about where the economy is going to go over the next year. That is a decision making under uncertainty. Now the opposite to that is if I can assign probability to that. Okay? If I can assign there's an 80% chance of this, a 10% chance of this, a 5%, a 3%, a 2%, then we say we're making that decision under risk because there's likelihood that says event's going to occur or not occur. So certainty, we know what's going to happen. We don't really talk about this in that class because it's too damn simple. We don't need any mathematical models for that. Uncertainty means I don't know what's going to happen. And risk means I can assign someone has assigned likelihood to that via probability, right? Which we've seen earlier. So the first one we're going to talk about, and I know you guys have seen these before somewhere, is we're going to talk about decision making under uncertainty. Okay, under uncertainty, which means I have no knowledge. There are 4 criteria we're going to use. There's more than this, but this is the classic 4, I guess, if you will, kind of demonstrate this. The classic 4, we're going to go through. These are decision making under uncertainty. The first one is called the max-min criteria. Okay, the max-min. It fits a pessimistic or conservative decision maker, and I'll show you that in a second. The second one we're going to talk about is called minimax regret. And it is also pessimistic or conservative, but it looks more at lost opportunity than payoff. Okay? It looks at like regret more so than it looks at payoffs, and we have to build a regret table. The simplest of these is something called the max-a-max. It fits an aggressive, optimistic decision maker. Go like a Tyler type, go big or go home. Okay. And the fourth one has an awful name to it. It's called the principle of insufficient reasoning. So anytime you make a decision, you say insufficient reasoning doesn't sound like you know what you're talking about. But what it's saying is, since I have no information, let's just add them all up and pick the higher. It's kind of a neutral, kind of in the middle. Okay. So let's go through each of those. Okay, let's go through each of those. The first one is the max-min criteria. You guys, this ring a bell? Has anyone seen this in undergraduate? Yes? You see it in what, production operations management, maybe? Maybe, I don't know. The stats? Yeah. Maybe I threw it in there one. Okay. You remember it, Stats? Stats? Okay. So this is based on the worst case scenario. It fits both a pessimistic and conservative decision maker. A pessimistic decision maker believes that the worst possible result will always occur. And a conservative decision maker wants to lock in a guaranteed minimum. So what this name implies, maximum, it's saying take the maximum of all the minimum payoffs. Okay, that's what the name, maximum in. Take the maximum of all the minimum payoffs. So what I do is I look across these decision alternatives. What's the worst I can do if I invest in gold? The worst I can do is what? Lose $100. The worst I can do if I invest in bond is lose 150. The worst I can do if I invest in stock is lose 600. The worst I can do if I invest in CD is make $60. Okay, $60. The maximum in says take the maximum of all the minimums. Based on the maximum in criteria, which of these would I choose? I would go with the CD. Okay, it's the maximum of all the minimums, right? I'm locking in that $60. I think this large fall is going to happen. You know, that's the pessimistic part. The conservative part is I want to lock in some return, so I'm going to go with the $60. Okay, that is under the maximum in, so we're saying CD here. Now the next one is my favorite one, okay, because I think a lot of times in my life I've made decisions based on not wanting to regret something. It is based on more on lost opportunity. We'll get to the spreadsheet at the end of this. It's more based on lost opportunity or regret than it is payoffs. So what we have to do to enact this is we have to build a sister table to the payoff table. Okay, the sister table represents regret rather than representing a payoff. Okay? The name kind of gives it away. It says, pick the minimum of all the maximum regrets. But I need to build a regret table first. Okay? I have a payoff table. I need to build a regret table. And I'm going to show you the process to do so. I'm going to make a little regret table up here just so we can go through it. Gold, bond, stock. So this table I'm going to build part of is based on regret, not payoff. So if a large rise happens, what would have been the best decision for me to make? If a large rise happens, what would have been the best, looking back, what would have been the best? Stock. So how much regret do I feel if I made the best decision? None, right? I made the best possible decision I could have made. So if we're talking about stock and it's a large rise, my payoff is, my regret is 0. Now, what's the second best thing that could have happened? Bond, okay, and the payoff is 250. Well, I made 250 and I'm happy with 250. I'm not, that's 25% return, I'll be happy with that in a year. However, I still have a little bit of regret because I could have made 500. How much regret do I feel then? 250. I could have made 500, but instead I made 250. So the difference between those is 250. Okay, the CD. Well, I went safe. I made $60. I could have made 500. How much regret do I feel? 440. The gold, I lost 100. I could have made 500. So I feel how much regret? $600 worth of regret. So we look at every state of nature first, okay? We look at every state of nature first. We find the best decision, and that gets us 0. So always regret is positive, right? Always regret is positive because it's all predicated on no regret and then more, right? So if we look at small rise, the best possible decision is the stock. It gets to 0. Now everything is predicated off that 250. Stock 250, bond 200. I could have made $50 more, so $50 difference. I made 100, which isn't bad, but I could have made 250, 150. I made 60, which isn't bad, but I could have made 250, 190. You guys see that? So this table now no longer represents payoff. This table represents regret. Make sense? Yes? Yeah. Okay. So now let's look at the decision criteria. It says minimum, max, regret. So what we're going to do is we're going to look across now the decisions and figure out the most regret I can feel for every decision. If I choose gold, what's the most regret I could have? The most regret that I could experience? 600. If I choose bond, the most regret? 400 if I choose stock, 500, oh, 660, you're right. And if I choose CD, 440. So of those values, okay, I think we got this. Of those values, this is called min-max regret. We pick the minimum of the maximums. What would I choose if I applied the min-max regret criteria? I would go with the bond. Okay? So under this criteria, I choose the bond. Both pessimistic, both conservative, slightly different way of looking at it. Does that make sense? Okay, let's go to the third one. This is the easiest one by far. Okay, this is max of max. This is, if it's an optimistic, aggressive decision maker. Optimistic means you think the best possible outcome will always occur. And aggressive means you look for the decision with the highest payoff. And as the name implies, we're going to pick the maximum of all the maximums. So if we look, the maximum for gold was 300. The best we can do if we choose gold is 300. The best we can do if we choose bond is, I guess that should be 250, not 200. If we choose stock, the best we can do is 500. CD, 60. The max of the maxes is the stock, so I choose stock. Now, the other way I could have done that is just look for the highest value in the payoff table, which is what Lou did. And we said stock, that's the max of max criteria. Now the last one is kind of, it's kind of a middle of the road criteria. It's saying, hey, you know what? I don't know what the hell is going to happen. So each is equally likely to happen. So all I'm going to do is for every criteria or for every decision, I'm going to add off the payoffs, the possible payoffs, and then take the one with the highest payoff. Basically, I'm going to say gold must add to 600. If I add that up, does it? Yeah, I think it does. No, it adds to 500. Negative 100, 100, 0, 200, 300, 500. This one is, let's see, 450, 600. Minus 100, 500, 350. So I add those up, this should be 500. And based on this, doesn't matter, I still invest in gold. It is like saying take the highest average payoff among that decision criteria. So if you look at this, we applied 4 different decision criteria and came up with 4 different solutions. Now, obviously, this is a textbook example, and that's why it comes out to be that way, because they made it that way. But a lot of times in the real world, when you do something like this, you may have 3 of the 4 point to the same decision, or 2 out of the 4. And you're saying, well, I really am pessimistic, or I want to be safe in this case, so I go with this. Okay? But it's none of them are wrong, none of them right, just a different set of decision criteria. I think Sue works in banking. Do you work with people making investment decisions? No? But I'm sure you realize, has anyone ever gone to a personal financial planner? Some of the questions they ask you are what? Like, before you even get started in investment, what are some of the questions they ask you? Yeah, they ask you what's your risk tolerance, right? They even give you their scenarios they play out. Like, are you a sweater vest wearing guy? Are you you wrestle alligators? Do you like risk? Do you, is it a slow drain going to kill you, or do you want to lock in? They want to know what your tolerance is for risk. They also look at things like your time horizon for the money. Those kind of things are important. But what they're trying to assess is those things, like what decision criteria am I going to apply? What portfolio am I going to put you in based on how you are with risk, right? They don't want to put you in something risky and then have, as soon as it goes down, you're the person calling saying sell all that. Because likely you're going to sell toward the bottom instead of toward the top, right? So they try to assess what decision criteria, because if you're risk averse, then maybe put you in something very safe, something that is guaranteed, all right? Now let us look at this, and you're going to like this as well. If we apply this, if we apply this using Excel, now I'll tell you what, we'll do Excel after a break. What I'm going to do though is I'm going to put up here a payoff table, and just so that I'm sure you understand it, I would like you to apply those 4 criteria to it. Let's be boring here, and I'll just say decision 1, decision 2, decision 3. State of nature 1, state of nature 2, state of nature 3. Let's hit on there. So let's say that is your payoff table. I want you to apply those 4 criteria to it. And all right, it's quarter till, so let's come back at 7 with this done. Okay, so let's come back at 7 with this done. And then I'll show you how to do this with Excel. Then we'll talk about risk. Talk about some expected value, which is a neat thing. And we'll go from there.